Hello ladies and gentlemen, what's up? It's Papa Bale. Welcome to the channel. And what we're currently looking at is the effect on the DC sine wave of running an additional radial pulse motor on the circuit. Look at that. I don't understand what's going on here, or what I'm looking at, but you can see that the wave is a DC spike, and it gets eaten up, I guess, when a magnet passes on the rotor down there, something like that. It's currently only hooked to the generator circuit of this pulse motor. So this is the beginning of the output cycle of this pulse motor. And this is what it looks like. That's pretty whack. I don't know what to say, but I do believe this has to do with me running the other motor. Absolutely. And the fluctuation in the voltage is the same reason for that. Because I would do an experiment but I don't know if this capacitor bank is liable to blow or not if I turn off the output power of it. And if I unplug the other rotor, it's going to start saving energy, and it's only a 2.7 volt super cap 500 farad capacitor bank. So and I would imagine that it'd be going faster than this. Let's take a look at that. It's going all right. I mean, it's not super duper quick, but so it's a little offset from the initial coil. These two would be considered series pickup coils, I guess, but this is where it starts. And when it's across from where it starts, you get the biggest thrust. So I can even put a coil at the beginning and put the reed switch like right next to it, and it'll probably still work, probably at almost optimal capacity. So I could have 4 coils going. I could have more than 4 coils going. I could put offset coils on there too. I don't really know what part they would play. I could add more magnets and more coils. There's tons of options at this point. Now that I got it running with my transformer pulse motor. Frickin' cool. Frickin'. Only he didn't say frickin'. Yeah. Alright. Alright, I'm going to call it then. That's pretty good for now. That's clipping at quite a rate now, since I jostled it around a little bit. A little bit more offset than it was before. Because if you get it like right on the cusp, okay, it's going to bounce back and forth. But if you move it off to the side a little bit, it just kind of scoots, and then it has an awesome push. And I think that has something to do with what Faraday discovered, or helped discover, because that is written in his notes, how the edge forces the movement along. That's the most efficient place to make contact with electricity or with mechanical nature. temperature is when it's right there at the edge of the magnet. And I'll get my green paper out and I'll show you what I'm talking about. Because it's really light around the edges, and that's where the force is the most strong. And I don't know, I can't get a reading on my electromagnets over here. I think only 2 of these are really electro, like, magnets that you can control. You got the 24 gauge strands in this coil right here. And then you got the 24 gauge strands in this coil right here. And that's it, man. And everything else is at the mercy of the magnets on the rotor for electricity. What I'm saying is you could, well, technically, if this stops spinning, there's no electricity. So if you turn the knob all the way down and take the power out of those 24 gauge strands, then nothing has power. You know? Okay. Yay. We figured something out. But this is awesome. All right, but I'm going to call it. Thank you very much. Peace out. Have a good night. Please subscribe. Hit the notification bell. See what's up. Bye now.